In this video, we're going to look at telescoping series. These don't fit the form of a geometric series like the first video does, but we will look at a technique where we're going to use some information and techniques from the past, partial fractions to be exact. And what we'll do is we'll rewrite this series as, we'll take its a sub n term, like we're going to write it as a sequence. Okay, now if we can split this up into simpler fractions using partial fractions, then we're going to be in good shape. This denominator, you can factor out an n, and it will leave an n plus 1 as the other factor. So this is identical to the partial fractions section that was in your homework. We're just going to rewrite that, and if you multiply through by a common denominator, n squared plus n, or in its factored form, n times n plus 1, then you get 1 equals a times n plus 1 plus b times n. We can let n equal 0. That will give us a times 0 plus 1 plus b times 0. Everything cancels, and that will leave us a equals 1. Okay, because the b term will go away. 0 plus 1 is 1 times a. The other good choice for n would be negative 1. If you let n be negative 1, and of course you're going to want to do that like the partial fractions video, I always put an asterisk by the equation you want to do your substitutions. So the one marked in red, we put a 0 through, that gave us a equals 1. If we put a negative 1 through, the a block cancels out. Just like above, the b block canceled out. B times negative 1 is negative b equals 1. So what does that tell us? B is equal to negative 1. Okay, on the next slide, we had a sub n which was broken into a was 1, b was negative 1. Now we can form a partial sum sequence. Okay, so if we let n be 1, because that would be the first term in the sum, that would be 1 over 1 minus 1 over 1 plus 1, and I'm doing that all from here, which should be a half, plus the second term, 1 over 2 minus 1 over 2 plus 1, plus, and then you guessed it, we're going to go n equals 3. After a while, you'll start to see a pattern unfold. This was 1. And so I'm just going to rewrite that as a 1. The halves up here, negative half plus positive half, those will cancel. Negative 1/3 and a positive 1/3 will cancel. And you'll start getting repetitive cancellations that way. Now, it started immediately. Some of these problems don't start canceling right off the bat, but this one did. Now, if we look at towards the end of the list, where maybe we look at the n minus 1 term, and then finally the nth term, just go all the way out. 1 over n minus 1 minus 1 over n minus 1 plus 1, right there. And then we go directly with the n's. It's the very terms you're looking at. Okay. More cancellations. That one and that one. This one, negative 1/4, would have had a positive fourth that cancels it. 1 over n minus 1 would have another one to cancel. Basically, what you're left with, once all the dust settles, is the very first and the very last term. So S sub n, once you've done all the cancellations, you expand the telescope, which is what we did. After all the cancellations, you contract it. We're left with 1 minus 1 over n plus 1. As you let n go to infinity, your partial sum that last fraction, as n gets really large, is going to approach 0. What's left? 1. So that original series telescoped out. We went through a lot of cancellations, contracted back in. We only had 2 terms that didn't get canceled. Take the limit as n approaches infinity, and whatever's left over, that's the sum of the original series. Let's do another one. Let's do one that already has a factor denominator, but we're still going to take it through the partial fraction decomposition and rewrite it, and just to have a second example. With these, it never hurts to have a bunch of examples. All right, so we're going to take 20 over n times n plus 2 Okay, so let's take our a sub n term. Split this up and let each factor in the denominator represent its own fraction. Multiply through by the least common denominator. All right, let me mark this in red. This is the one we're going to keep coming back to. Now, if you look at the split fractions, good choices for n are going to be 0 and -2. Those are the zeros for each denominator. And if you choose those, it'll help you block out a and b one at a time. Excuse me. So let's go n equals 0. That's going to be 20 equals a times 0 plus 2 plus b times 0. So that section's gone. 20 equals 2a. So that tells us a is equal to 10. And we'll hold on to that. Now, if n equals -2, back into the red asterisk equation. We're going to get 20 equals a times negative 2 plus 2 plus b times negative 2. That tells us 20 is equal to negative 2b, and so b is equal to negative 10. Okay, so let's remember, we're going to go right here. A is 10, b is negative 10. A was 10, b was negative 10. Writing that as our nth partial sum term, also keep in mind we're going to build these one at a time. When n is 1, 10 over 1 minus 10 over 3 when n equals 2, 10 over 2 minus 10 over 4. You could call that 5/2 if you like. We could have just as easily left those first numbers as 10 over 1 and 10 over 2. That part's up to you. The main thing is being careful when you telescope it out and being super careful when you cancel opposite signed pairs. Moving up to 3, 10 over 3 minus 10 over 5, because it'll be 10 over 3 plus 2. All right. Now, I do already spot a cancellation here and there, but I'm going to go ahead and build out some more terms, maybe 2 or 3 more. We need to keep building until we get consecutive cancellations. And you'll see what I mean here in just a minute. Okay, if n equals 4, 10 over 4 minus 10 over 4 plus 2, that's 10 over 6. 10 over 5 minus 10 over 5 plus 2. And this will be enough to start seeing consecutive cancellations. All right, let me go back to green. Okay, so starting at the very beginning of S sub n, we had 10 minus 10 thirds. Later down the line, we had a 10 thirds that canceled it. Our second group of terms, we have a 5. We don't have a 5 anywhere down the line to cancel, so far it's hanging in there. Negative 10 fourths has an opposite that will cancel it. 2 and negative 2 are also opposite pairs. Once you get to where you have consecutive cancellations, then you don't really need to build any more terms. Now, it took us 2 values of n, and it took us to the third group before we got consecutive cancellations. So that means in the back, we're going to need to build 3 back terms. And let's look at what that means. Okay. So I'm going to need, the last one's going to be n. The one before it will be n minus 1. And the one before that will be n minus 2. Okay, so back up there at the very top, your a sub n, 10 over n minus 2 minus 10 over n minus 2 plus 2, which is just n, plus, now go back, 10 over n minus 1 minus 10 over n minus 1 plus 2, that's n plus 1. And then finally, the n itself, or just the two terms you've got for a sub n, 10 over n minus 10 over n plus 2. Okay. What I do is on the front end of S sub n, the partial sums, is I count how many blocks it takes to get consecutive cancellations. When we hit that red 3, the third group, all of our terms started canceling consecutively. There was never any more gaps. So I knew that it was going to take 3 terms from the back end to do the same job. Why is that? That has something to cancel. N minus 1, if there was a term here, its back term would be, because it'd be n minus 3, it would be n minus 3 plus 2 is n minus 1, and that would have a cancellation as well. So basically, the way to look at it is these two terms survived the front part of the list, so these two terms will survive the back part of the list. S sub n, once all the dust settles, you're going to have a 10, a plus 5. Then from the back half, a negative 10 over n plus 1 minus a 10 over an n plus 2. And as n goes to infinity, those back two terms are going to go to 0. And that's the idea, is if you can get your partial sums to have a finite limit, then whatever that finite limit is the sum of the original series. Okay, so as n goes to infinity, those two terms will go to 0. And so you guessed it, we're going to have a limit of 15. Therefore, that original sum that's a 20. The devil's in the details. There we go. Has a sum of 15. That's one of the downfalls to not having a geometric series, is if you have a geometric series, as long as that rate of change is less than 1, you have a over 1 minus r as the formula that gives you the sum. If you don't, then you don't always have the luxury of that formula. Sometimes you have to take your term, break it apart, which these two are designed to be factorable, and break them into two fractions using partial fractions decomposition. Once we telescoped out, wrote out several terms, starting with 1, going all the way to n. We always have to look for those consecutive cancellations. And once you start getting those, however many terms survive the front end will be the same number of terms that survive the back end. The good news is the terms in the back end, you'll usually have a fixed number over some n terms. And when you dial up the heat on n and let it go to infinity, those back terms are going to go to 0 anyway. So you can almost bank where the terms in the front of your telescoping series that survive, the ones that don't get canceled, when you add those up, that's going to be the sum of your series.